because people are still doing their projects.
Yeah, we are. Can you make sure the audio is working on the YouTube?
Yeah.
Yeah.
I think that's probably the best idea.
I think the audio, yeah. Yeah, so I think we'll wait a couple more minutes, then I'll just do the introduction.
Yeah. We can wait till.
Don't worry, take your own time. I don't mind at all.
Yeah.
Yeah.
Alright, the one person just left.
Okay. So yeah, I think it's fine. We can start the guest speak session, and we can just have it on YouTube for people to watch after they're done working. I think that's probably the best course, right?
Yeah.
Okay.
Okay.
So yeah, you can start.
So hi everybody in the Zoom and hi everybody watching live on YouTube. Right now we are going to interview Sandeep Shilawat. He is a seasoned technology thought leader with a focus on federal and fintech markets. His experience in building cutting-edge systems and experience in cybersecurity in the age of cloud makes him an invaluable guest speaker. With a track record of managing high-impact transformational initiatives, Sandeep will enlighten participants about the importance of cybersecurity and its relevance in the context of cloud technologies. So Sandeep, thank you for joining and taking your time out to help us, and we can start with you.
Hello, everyone. Thank you for inviting me. It's a very unusual kind of talk I would be giving today. I see a few people online here, and I'm sure some of them are watching on live stream, and maybe some of you would watch later. I was just telling Balash that I would not use any dad jokes, but I do have one, which I'm definitely going to use. So the introduction my friend gave you here, he called me expert and thought leader a couple of times. So I have a definition of expert that I would like to share. Expert is someone who knows more and more about less and less until he knows everything about nothing. Okay, so that's the definition. If I am being called cloud expert, the baseline is I probably know everything about nothing in cloud. So let's start with that. And I don't see much laughs out here, so I think it didn't work.
No, me and Derek here are laughing all we can laugh about.
Well, my daughter did warn me about it, so okay.
Just keep it rolling.
That's out of question, so I can really start to talk now.
Yeah.
One of the things I always ask people, hey, what is cyber, right? And to my surprise, a lot of them don't know what cyber is,
Yeah.
It's basically a computer or a computer network. If you go to Webster, that's what it's called. And cyber security is actually security of computers. I'm part of one of those security groups with law enforcement officials. And, the world has been changing in terms of cybercrime a lot. I have been victim of, actually, I wouldn't say victim. I actually was invited by a Nigerian prince to share his wealth on oil in Nigeria, as long as I can give him my bank accounts. I also have been invited to free trips for 6 days and 7 nights, as long as I can give them a credit card and social security number. I've been invited, actually I've been victim of, I've been criminal of Custom and Border Patrol and IRS. The law enforcement official already left to catch me, apparently, right, because of the calls I get. In fact, the crimes have, this cyber crimes have gone so much that my home phone has pretty much become useless for me. If I get a call, I don't even pick it up. I remember, for emails, that's happening because so many emails would come through and we wouldn't actually read any of those emails. But now the phones have become useless. So I asked that person, this law enforcement official, what is going on, right? Why so much crime in cyber? So the gentleman did tell me a very simple thing. We are in capitalist world and we're driven by greed. Right, so whatever is valuable is prone to be stolen. Earlier, we used to have money in the banks, in homes. Right, we'll keep in our treasury, in chests, under the bed, in the pillows, wherever you can keep the money, the ornaments. So people used to attack homes. there used to be a lot of robberies. Now your assets are in computers. You have bank accounts, which you think is the money, but it's just a display, an HTML page which is showing you some number that people have made you believe it's your money. You look at another HTML page, you see a bunch of stocks and securities. People have made you believe that those are your assets.
Yes.
So when those have become your assets and your wealth, it is obviously it will be under attack. So the grid has a new target now, your computer, your network. And I remember in around 2000s, 2003, 2004, there used to be a book from NSA that got published, Web Entangled. It was a PDF free available on then Yahoo, Google. You guys are too young to remember that. There used to be a Yahoo search as well. So I downloaded the book, and there were free Google queries that you can do. And one of the Google queries you could do is to find the admin privileges for Apache web servers. And I just did a Google search with that query just to learn, right? You know, you get a course now, Certified Ethical Hacker. So I took that query, I put it in the search, and I used .in as the site's domain, meaning only Indian websites.
Yeah.
And the kind of information that came out, 90% of Apache web servers had root privileges available for you to read. Meaning you could go into their web server, log into as a root account, and see everything. Because this is a recorded session and will stick around for a long time,
Yeah.
I will try to carry my plausible deniability on this issue, right? And may plead fifth because it implicates me in any way. But the fact is, people have not been very aware about cybersecurity, right? Even today, I can go into my basement and look at the router, and there's a long string written in the back of the router. That's the password for that router.
Right.
So if somebody who's fixing my heater or cleaning my duct can go to the router, take a picture, and sell it on the internet, then they will have access to everything that I do on my computer.
Yeah.
So that's the kind of security we have. There are two kinds of securities we think about. One is the retail security, right? The retail customers like you and me, families who have homes with Wi-Fi, routers. Last I checked on my home computer, there are 38 devices. I'm sure you guys are, those who are more tech savvy and gadget oriented, they have 50, 60, 70 devices. Some of them are DVRs, some of them are refrigerators, cell phones, bulbs, light bulbs. They are all on Wi-Fi and they are all vulnerable. So since you have 50 devices, that means there is a 50 into 100 ways of getting into your house network.
Yeah.
So that's a retail security, right? And then a lot of things have been done, endpoint security and all. And a lot of us fall victim to. In fact, in the latest survey you would see, there are a few $1 billion that were lost into the retail security world. We all of us are such an easy target. Such an easy target.
Right.
If you have your credit being monitored, which you probably don't have, I don't know how many of you are eligible for having a credit, but if you do have a credit and it's being monitored, you will see your social security numbers, your emails, your phone numbers, your names, your date of birth are for sale on dark web.
Right.
For those who don't know what dark web is a part of internet that is actually works with unregistered IPs and is a separate set of network that's accessed by criminals for conducting criminal activities. And then the second group that needs protection is enterprise security, the companies, the enterprises, the agencies, the nations, the states, the counties, the ships, the aeroplanes. These are enterprise security components that needs to be protected.
Right.
And they make critical part of nation's infrastructure. Meaning, if you actually damage any of those, the impact is more widespread. If you rob me, it's just I getting impacted, or me or my family getting impacted.
Right.
But if you rob a company, you're probably going to deprive a nation of something. Suppose you shut down Google today.
Yeah.
Let's take an example.
Right.
That'll probably bring down America to its knees. Right? So it's pretty dangerous thing if you bring down the Department of State. And it has not happened. It has happened before. The amount of loss that was estimated by 4-hour shutdown of an agency was pegged at $22 billion. So if you bring it down for a week, you're probably losing hundreds and billions of dollars.
Right.
More than that, you're actually showing that all of us are very vulnerable. Very, very vulnerable in different ways. So that's just to give you an idea what cybersecurity looks like, right? And you guys are high school students, so I need to be keeping it a little simple, right? One is a retail security model, one is enterprise security model.
Right.
The actors typically are thieves, right? Stalkers, right? Some of, back in India, I was visiting a couple of years ago, there are Wi-Fi stealers, they sit outside in the Wi-Fi range, admin 1, 2, 3, and you're just using the router for stealing the internet.
Yeah.
Then there are criminals, the Nigerian princes, and all those great people that give you free money as long as you share your information. And then there are organized criminals. Those criminals are part of a gang that are trying to, they intend to obtain a sustained income out of this business, meaning robbing, stealing information, and stealing money from people is their business.
Right.
They have to sustain it, so they have to target certain amount of people daily, monthly, annual basis, and that number needs to grow because this business is flourishing. There are actually gangs, cyber gangs now that follow people and rob them. And then there are state and nation actors. These are the most dangerous people. They never steal your money. Sit on your network forever and don't do anything unless they decide to inflict a damage on you. US, Ukraine, if you see Ukraine was attacked by Russian actors, they're trying to bring down Ukrainian infrastructure. Ukrainians entered into Russian networks. So these are nation state actors. They're very smart. They have all the infinite amount of resources, the infinite amount of skills, and intend to damage.
Right.
So if they choose to damage somebody, it's very easy for them.
Right.
That's the actors, right? Then what are the models of security, right? Earlier, if you do watch, I'm a movie buff, so I watch a lot of westerns, right? You see the guys in the, Clint Eastwood and those guys go on horses and rob a bank somewhere in a remote town.
Yeah. Yeah.
And then these guys are protecting that bank, right? So as long as you protect the bank, you're okay. That's called, castle and moat approach, meaning you actually protect the castle with certain, like watchtowers and stuff.
Right.
And as long as you're within the castle, you're safe. There's no guarantee if you're outside the castle. That has been the model for the last 20 years that industry has been using. So if there is an insider, as long as you're in the network, you are a trusted user. If you're outside the network, then it's very hard to get in. There used to be something called DMZ, demilitarized zone. You have to go through the firewalls, gateways, and so on and so forth. The other part of the same approach is called defense in depth. Means you have one model of security, you're going to protect, and then you're going to add another model of security on top, which is basically if plan A fails, then there's a plan B fails, then there's a plan C, and there's a whole bunch of other approaches. So it's kind of a layered onion kind of approach.
Right.
Lately, then those, again, you guys are so young, you wouldn't know this, but TCP/IP was invented to enable internet, meaning it was supposed to be a trust-based connection, meaning your computer has a lot of ports open, and it is okay to connect first and authenticate later. So you would get into my port, then I'll decide whether I should, authenticate you or not.
Hmm.
And that is the fundamental issue with the network security these days. A lot of bad actors are getting in
Right.
because of the trusted connections, and then they're doing lateral movements and all kinds of stuff.
Right.
So the new approach that has been proposed 3-4 years ago, and federal government is actually mandating, at least within the United States, to use, called zero trust security approach. Trust nobody. You cannot get in unless you're authenticated first.
Right.
And that zero trust approach is actually being implemented all over the industry today. That has 7 pillars. Each pillar has to be protected: device, user, network, data, application. These 5, and then there are 2 other pillars: governance and analytics, visualization. Those are 2 horizontals, and 5 are the pillars. Meaning, as long as you protect your devices, protect your users, application, data, and network, and then there are different maturity levels to that protection. Do you have MFA enabled? Is your data protected? Is data encrypted? So that whole approach is called zero trust approach. I'm going to assume that all of you know what cloud computing is.
Yeah.
So
Yeah.
in cloud computing, there is additional, very undefined way of doing things. This model is called shared security model, meaning if you are working on cloud computing, you are responsible for certain things, and the cloud vendor is responsible for certain things. So that's the models of security, right? One was a castle mode, then you have defense in depth, zero trust, and shared security. I think those are the jargons you should remember. But the world where castle and mode security used to work has gone now.
Right.
The reason is, and because this topic is cybersecurity in the age of cloud, earlier that approach worked very well because there were data center and everybody is operating on their own. They never connected to each other. The only way they used to talk to each other was through internet. Now, since you are in cloud computing environments, it is multi-tenant environment. Meaning, everybody is sitting on the same network, in same data center or same infrastructure, on the same property servers and same racks, right? It's maybe one company, other company probably sharing the infrastructure.
Right.
While they're doing that, I don't know how many of you know this, Google owns one of the biggest networks in the world, followed by Facebook and Microsoft shared. Meaning they own more fiber in the world than any telco company.
Right.
Followed by that, I don't know how many of you know this, but Google makes its own servers and is the biggest server manufacturer in the world. And followed by other companies, that big players that I mentioned.
Right.
Meaning the supply chain of chips, the network, the infrastructure, the data, the application, all needs to be protected. And these companies who own that are protecting them, but they have given you something called shared security model. In that world, if something happens, see, like the old Bank Western example I was giving you, if one bank was robbed, it doesn't mean the other bank become vulnerable.
Right.
And getting from one town to another town, it used to take a long time. Meaning, in the computer world, exploiting vulnerability from one data center doesn't mean you could exploit another data center and the other data center. However, if you look at what happens in cloud, if something is exploited in Australia, Russia, China, it will probably take microseconds that same vulnerability that can be exploited within the United States.
Yeah.
Everything has become connected, meaning the cloud has the zero-day exploits, the speed to get to zero-day exploits across the globe has literally gone down from days and months to seconds.
Right.
If anything is happening somewhere, you probably are vulnerable and being exploited as of now.
Right.
There are many examples that is happening. So that's what cloud has changed for you. Other thing, people say about cloud computing, right? So cloud computing means everything is concentrated in few places now. right? If you are in Northern Virginia region, Ashburn has 70% of internet traffic of America, Ashburn, Virginia. Because most of the traffic is passing through that. There is a benefit of that. The benefit is you can easily protect it.
Right.
Physical security, computer security, network security, you can put best of your resources there.
Right.
But then you are actually adding a risk, a systemic risk, a geographical risk, a concentration risk, a policy risk by having it there.
Yeah.
Now cloud is forcing you trade-offs. The cloud allows you to innovate so fast, you can do a lot of things very cheaply and turn them off. But then it's also facing, hey, you are part of the systemic risk now.
Right.
If somebody attacks Ashburn, or if Ashburn has an electricity issue, grid issue, then you're probably already in trouble. I think the other thing cloud has done is while it enabled innovation, it reduced the barrier to entry for attackers as well.
Right.
Right? The cheapness or the lack of, the lack of money that actually was a barrier for innovators
Right. Yeah.
was a barrier for attackers as well.
Yeah. Yeah.
As you reduce the barrier for innovators, the attackers also got the benefit. And they're probably exploiting it. The attackers, a zero-day attack is basically when you know something is released, on the first event of release, those vulnerabilities are called zero-day vulnerabilities. And if they get exploited right then and there, these are called zero-day exploits. And 50% of world's attacks, cyber attacks, are zero-day exploits that occurred on the computers where patches are applied or new things are done.
Right.
The attackers are actually ransomware, right? I was actually sent an email saying, hey, unless you give this, contribute or buy this Bitcoin, right, you will not get your computer back.
Yeah. Right.
Then there are malware people, right? Hey, click this link here.
Yeah.
I get it twice a day, that kind of. Cryptojacking, right? Your computer is running slow, probably then somebody's mining Bitcoins in your computer.
Yeah. Right.
Spear phishing, if you are important enough, people will actually target you and try to, hey, I know your boss or I know somebody, and now they're doing phishing as well. Basically, they mimic your voice, they call you, like, kids are getting called in mom's voice, yeah, I am in trouble and can you give me this money or send the money here or do something like that. So your world, the young people that are entering that world has become very different now.
Right.
The examples, I think I'm running short on time, so I will give you a few quick examples. SolarWinds was a company that was exploited. It used the open source code.
Right.
So the hackers got into the code of the original software, which then got deployed into the SolarWinds company, which then got distributed to the whole world.
Yeah.
And the attackers were sitting on the server for 6 months, exploiting and stealing all the data. In fact, just last week, a new vulnerability was found in Microsoft Azure that was actually Outlook Web Access was exploited through forged tokens by Chinese hackers, and they stole data from 25 agencies. Means they were sitting on emails and stealing the data from the emails.
Yeah.
Every day there are hundreds of examples coming out, and now the next step here is AI. You guys are going to find out that ChatGPT is not. It's a good thing for your exams and stuff, but they're probably stealing your data as well.
Yeah. For sure.
And if you guys know what quantum computer is, and if it becomes reality by the time you get into your businesses and jobs, you're dealing with a new set of threats than what you're dealing today.
Exactly. Yeah.
There are a lot of topics to cover, but I was trying to keep this introductory for all of you.
Right.
I hope this was useful and valuable.
Definitely.
I'll take questions now for the next few minutes.
I actually do have a couple of questions from my end. So you mentioned cyber attacks, right? How does cloud adoption really affect response and recovery strategies to cyber attacks?
So first, you would like to know what cyber attack looked like in a traditional data center, right?
Yeah.
Yeah, right. It was people used to come through DMZ through legitimate means, exploit customers, right, and go through stealing the data. And they used to sit on the networks forever, and nobody never knew.
Yeah, right.
Right? But if you go on a cloud, right, fundamentally the cloud vendors are protecting themselves. Their networks have best of the cybersecurity protection that they have. Their chips are secure, their computers are secure, their networks are secure. What they don't allow you, like guarantee you security of the one part that you're responsible for. It's called shared security model, something operating system and above.
Right.
If you are using infrastructure as a service, operating system, if you are installed this, and if there are vulnerabilities on that OS, then they are subject to exploits. But now cloud vendors are actually scanning if it's in their environment. They scan and alarm you right away. Hey, somebody is exploiting this, or you have this vulnerability and you need to take care of it. So there are multiple layers of protection. The one biggest thing that cloud vendors allow you to do is actually they give you transparency.
Right.
They let you know that there is a problem. In the traditional data center world, you can sit there for years and you wouldn't know that there is a problem.
Right.
Yeah.
Right. Yeah, that's great. I actually had also another question on like, what's blockchain technology's role in like all of this? Because when you're mentioning cybersecurity just as a whole in general, the first thing that comes to my head is just blockchain tech. At least it's like a new and improved thing. I mean, those of you who are at home who may or may not know of it, do your research. But yeah.
So remember, what is blockchain, right? Blockchain has two components. There is a cryptocurrency component and there is a proof of work component,
Right.
right? Cryptocurrencies have their own debates, right? We really don't know unless the world financial system supports it,
Right.
which US is currently very reluctant and trying to kill crypto.
Right.
I think there is a separate half an hour session needed for that.
Yeah.
But there is a significant value into the proof of work part of it,
Yeah.
like smart contracts, right?
Hmm.
I think there is currently, we all use user IDs and passwords,
Yeah.
right? For everything. And then MFAs and then fingerprints and all that.
Yeah.
That is authenticated trust-based protocol, right?
Yeah.
Blockchain, the proof of work, is a trust-free protocol. You don't have to prove anything. You don't have to identify yourself to
Exactly.
get access to anything,
Right.
which essentially means you don't need this entire identity and access management systems. There will be cases where you would need them, but if you are doing an open world, exchanges or marketplaces or things that you want to access but you don't want to identify yourself,
Yeah.
there are millions of this situation. Every such situation, blockchain technology has a scope. The challenge though is the protocols that are developed today, right? The distributed ledger protocol. You need to pass the whole thing over network. As the blockchain network grows, the ledger size becomes so huge, it's very hard to pass it, back and forth. It depends on the network to be available.
Okay.
And then second thing is, how does enterprises participate in it?
Yeah.
One last thing I'll tell you is, remember the stock exchange works in the exact same philosophy that open contracts or this proof of work philosophy works. It works on something called free market theory. It believes that the good actors will overpower the bad actors for that market to function fairly.
Right.
We all know what happens in stock market. The big actors actually manipulate and take the stock.
Exactly.
It's the same problem with blockchain, proof of work, right? I think the challenge there is it assumes that the good actors would actually overpower the bad actors when the ledger is being authenticated. But nation states can easily manipulate that. People have seen that happening in Bitcoin and a few other worlds.
Yeah.
So I think the risk needs to be mitigated. Mining Bitcoin or blockchains, right? I think that's another energy inefficient part of it,
Yeah.
which needs to be. But cloud is where they're mining now, and cryptojacking is actually where they go and sit on your computer
Exactly. Yeah.
and your laptop and mine.
Exactly. Yeah.
Ultimately, I think those are the issues that needs to be mitigated. But I think that's how I would say it will play into the entire ecosystem.
Right.
Yeah. So I have a question. So like you previously said that like how these big companies like Google, Microsoft, and Facebook, they're doing things to protect themselves, but like them individual employees who are doing the day-to-day businesses on the computers, how can companies like foster like a culture where the employees can protect themselves from harm, and like if they see something is wrong, like report it to make sure the company doesn't get hurt? Like what type of things can the company do to enable that?
Currently, what companies are doing, they're doing training, right? Education is the only way. Earlier, when we built our houses, we never thought, we need ADT security systems or savvy locks and keep the money out of the house kind of a thing, right?
Right.
It is the same thing with computers.
Right.
Today, when we get computers, we need to make sure we don't keep sensitive data open to the world.
Right.
We need to make sure that there are, biometrics or some sort of additional security layers. The basic cyber hygiene has to be followed. There is the whole topic of insider threat. Most of the enterprises today that get hacked is because of a careless employee. They are not malified people. They don't have bad intents. They're just careless. And one of the guys in Hawaii, I don't know whether you know that case, he actually put his password on the monitor, and that led to a nuclear missile warning across Hawaii. Hawaii was shut down because the dude had a password on his monitor. There's a picture of that. He took a selfie, and behind him was the monitor on which the password was there, and the hacker went in and did that.
Right.
So I think education is the only way. And when you're doing a computer or building a system or writing a code, think about security. I think that's the. It's not an optional thing that you don't think about it. You probably wouldn't qualify in the new world if you don't think about security.
Right.
Yeah.
So I think education and training is the only way. You can force punishments and stuff, but that rarely works. I think combined effort as a community, whether it's your employee or family, and education, those are the only two ways forward. And you guys are pretty savvy. You guys understand at this age you're knowing about cybersecurity. First time I heard cybersecurity is when I got into third year of my job in computers.
Right. So yeah, thank you. Thank you so much. That was an amazing talk.
It was really, I learned a lot. Yeah, thanks.
Thank you.
Yeah. Is it all right if we share your email with those who are kind of like listening at home? So if they have any questions, they can email you there.
Yes, I would say that would be fine.
Okay.
Depending on the audience, how many, and if it is national audience or international audience, but it's okay to share.
Okay, thank you.
Yeah.
So we'll put your email in the chat in YouTube for anyone who wants to ask some questions there. But yeah, it was amazing talking to you. It was amazing having you here to talk.
Yep.
Hopefully people can listen back when this is uploaded later individually. And yeah, thank you so much.
Yeah, thank you.
Thank you very much. I appreciate and enjoy. This is National Interns Week, so thank you for giving me the opportunity to speak here.
Yeah.
Thank you so much.
Yeah.
Have a nice one.
Thank you.
Have a nice
Bye.
one. Bye-bye.
Bye.
Thank you so much for everyone who joined. Super excited about this event. And again, thanks for inviting me. Today, we're going to talk about augmented reality, virtual reality, 3D applications, and how you can build an application yourself in 15 minutes or less. I'm going to start by saying, Hello, I'm Milan, founder of Echo 3D. I did my master's in computer science at Columbia University, specializing in augmented reality and virtual reality and computer graphics, and my undergrad in computer science and electrical engineering. So I'm a certified nerd and a big believer in 3D applications and the intersection with cloud technology. Now, before we start, I want to level set here a little bit, define these terms that we're all going to use a lot. Most of you probably know them by heart at this point, but let's kind of just level set and make sure that we're all on the same page. So virtual reality, or VR, is when everything around you is fully digital or fully immersed in a 3D environment. And basically everything you see is being projected into your eyes through some headset or glasses that occlude everything you see. You're controlling and interacting with the world with some sort of controllers or your hands, but everything you see is being projected into your eyes, and you're fully immersed in this kind of digital construct. As opposed to augmented reality, or AR, which you still see the real world, that world is being overlaid with digital content. And that world is basically being changed through digital content that's being overlaid on top of it. You're looking at the world through some optical see-through, like kind of glasses or a headset, or a camera see-through, like a phone or a tablet. And again, that's kind of the biggest differentiation. A good way to understand this is the amazing movie Space Jam, in which we have Michael Jordan being teleported into Looney Town. Everything around him is kind of this digital construct. He's fully immersed in the Looney Tunes world, interacting with Bugs and the other Looney Tunes in a fully cartoonish world. As opposed to what we have later in the movie, in which we have Looney Tunes coming to our world, playing basketball with Bill Murray and Jordan and kind of this real life board. So that's basically the differentiation. Either we are being teleported into Looney Town, or Looney Town is coming to us. Now, this is obviously a comical example, but another kind of really great example of this is something that we all know, something like Pokemon Go, an amazing example for augmented reality, in which you have people running around and kind of interacting with digital monsters that are not actually there. As opposed to virtual reality, here we have an example of Beat Saber, a really cool VR game, kind of beat style game that allows you to slash cubes based on the rhythm of the music. But as you can see, you're kind of fully immersed in a digital environment, in a 3D construct that is kind of fully surrounding you. Now that we understand the kind of difference between augmented reality and virtual reality, another example of augmented reality that is really close to my heart, and the pun is definitely intended, is my thesis project at Columbia University, where we took CT and MRI scans, converted them into 3D models, put them on these smart glasses called HoloLens by Microsoft for the physician to wear, and then the physician was basically able to see the patient's heart floating above them during surgery. It was an amazing, amazing experience, and an amazing use case of augmented reality in the operating room. The hashtag was AR in the OR. And what's cool about this is the physician basically got this 3D reference map of the patient's anatomy in real time. Again, amazing use case, amazing execution. But in order to achieve that, I had to do something that I really, really hate, and that's waking up super early in the morning. I had to be in the hospital around 6 a.m. to take those 2D scans, convert them to 3D models, deploy them to these glasses, redeploy the application for the physician to wear. And as a developer, that process was so frustrating. It took so much time. And all I wanted to do basically is just to manage 3D assets and deliver them to an air device, switching on a heart, to an aorta, to lungs. Why was I, an engineer, required to be in the OR to basically switch up 3D content? And when we saw this problem, we kind of started talking to other developers who were building applications in retail and shopping, data visualization, games, and they all said the same thing. There was no easy way to manage and deliver 3D data. But again, if you think about it, this problem was kind of solved in 2D. If you want to build a website, you can use something like Heroku's or kind of cloud platform, upload images and videos. If you're building a mobile app, you can use something like Parse or Firebase as your back end as a service. So we went from web to mobile to now this kind of new technology, AR, VR, 3D, XR, immersive, metaverse, call it whatever. Question has to be asked, who's going to build the same platform for this new type of content? And you've guessed it, that's what we do at Echo 3D. We are a cloud platform for 3D applications that basically provides tools and network infrastructure for creators and developers like yourself to build games, AR/VR experiences, and any 3D application that you can think of, from NFTs to face filters to whatever you think. We kind of make sure that you can upload and handle 3D data, and then we stream it all over the world. Super excited about today's event. We're going to share demos. We're going to do a bunch of interactive stuff and try to build applications together. So really, really excited about this. And let's kind of get started. So the same way, if you think about it, that you don't need to be a web developer to update a blog post, you can drag and drop an image or video, and suddenly they appear on a website or a mobile app. And if I'm in New York and you're in California and we're both watching an episode on Netflix, we automatically get the best streaming experience. So at Echo, we basically translated these concepts into the virtual reality and augmented reality, providing you with a way to manage and deliver 3D data and get the best 3D streaming experience. And what's interesting here is this kind of bi-directional connection between data and location or data and target. If you think about images and videos, you as a user, you can't move an image or a video on a website. But you can definitely move a 3D couch across the room or a 3D avatar inside a game. And that location needs to be updated on the cloud. So that's kind of the big difference between how we handle 3D content and 2D content, and why it's so different, and why we need new tools to basically manage 3D content. So this is basically what we built, this kind of content management system and delivery network that's kind of extremely focused on 3D content. And today I'm going to kind of share, again, some interactive demos and upload data and allow you to stream it to your phones right now through our platform. So you can kind of enjoy augmented virtual reality, but also learn how to build applications really, really fast. If you go to our website, you can register for free, absolutely for free. Have a generous free tier that you can register for. Just go to our website, www.echo3d.co, and you'll be able to build application exactly what I'm going to do right now. So once you go to our website and register for an API key, you're going to get access to our platform right here. Hopefully you can see my screen now. On the left, you should be able to see kind of our platform, and on the right, you should be able to see my phone. What I'm going to show you right now is that after you register to our platform, you get this API key. It's basically a project key that allows you to start building applications. You can have multiple keys, which basically means multiple folders or multiple repositories of 3D content, that they basically allow you to kind of store and stream assets. Aside from that, we have all these different kind of software integration with Android and iOS, Unity and Java and Swift and Flutter and so on and so forth. And we're going to dive into those as well to basically make sure that you can build applications to whatever platform you want and stream the data from the cloud to your device. Later, we're also going to share kind of an in-depth Unity demo. So let's get started. So we have access to the platform. We have our key. Let's add some content to the cloud. So I'm going to click the Add to Cloud button right here. And in this menu, I'm able to add kind of images, videos, 3D models, and I can also use our kind of collection and search engine of 3D assets to get access to already 75,000 free models that you can use to build applications right now. And it can literally be anything. All of them are free, and I can do something like, let's say I want to upload this skyscraper. I'm going to upload it to our cloud. What happens right now is that we take that 3D model, we convert it, we compress it, we make sure it works on any device out there, and that it's kind of available to stream everywhere on the planet. Once it's done, we have this model right here. We can see that the original file format is OBJ, but under the hood, if we click the kind of downloads button, we'll see that our platform already converted it to other formats like GLB and USDZ. So this basically means that your kind of content is already ready to be consumed on different platforms and has these kind of different file formats. But let's start with something super, super simple. Let's view this 3D model from the cloud to our devices right now. So I'm going to click this button right here. It will open a QR code, which you can scan with your phones right now if you're watching this live. I'm going to do the same with my phone that you can see on the right. Basically opening the camera, putting the camera in front of this QR code, it redirects to a website. You don't have to install anything. So this is kind of an implementation of Web AR. You need no installation, nothing technical. Just scan a QR code or go to a link, and basically that link will show you that same Empire State Building right now. So let's see how that works. So I'm going to do this. We're seeing the Empire State in kind of the browser. If I click C in AR, camera opens up automatically. If I move the phone a little bit, the Empire State Building will appear on the floor next to me. How cool is that? I can pinch it a little bit to kind of move it around and make sure it kind of fits the camera. Super, super simple. How cool is that? I can walk around it, walk inside, super simple. So again, all I have to do is just upload it to Echo and then automatically stream to the device by scanning a QR code. Super, super simple. Now, this web page is also something that you can kind of embed anywhere. If you use this short link that's basically the same as scanning the QR code, you can use the short link to share it to anyone. Basically, give everyone this link. It should open up automatically on any Android or iOS device, and they'll be able to see the Empire State Building right now. This is, again, really cool to make 3D content shareable and highly accessible. And you can also, again, embed this in a website, and then people can basically have access to 3D content on top of your website if you're building an e-commerce website or a store or anything. Okay, so we saw one example of web. Another example I want to show you is mobile app. So maybe I'll open a mobile app right here. Let's do this one. Data will stream from the cloud to the mobile device at this point. And we should be able to see the same building in front of us. There we go. Yeah, there you go. So very similar stuff, but now instead of a web browser, we have kind of a mobile app that is kind of installed on the device. Super, super cool. And again, just to show you that you can choose any platform that you want and any kind of technology. It could be mobile, it could be web. And later we're also going to see how we integrate Echo with 3D game engines. Perfect. Let's look at other types of content and other things that you can kind of do in order to see and kind of basically deliver 3D content. So what we saw so far was basically allowing you to see a 3D asset on the floor next to you. That's called surface tracking or surface detection. Basically using a technology called SLAM that allows you to kind of triangulate the area around you and project a 3D model on top of it. Other things that you could do is stuff like image recognition and face recognition. So let me show you how that works too. So if we click this button right here, again, opens the QR codes, but now instead of do see on the floor, I'm going to do see on an image. If you're watching this live, again, you can kind of scan it yourself and see it with me. I'm going to scan this QR code right here, redirects to a website. Again, you don't need to install anything. Camera will open up. Basically, will instantiate, and then the Empire State Building will basically pop out of the screen. Now, instead of having the Empire State Building sit on the floor, it sits on this image. This image right now is a QR code. This image could be anything that you want. It could be a magazine or a business card, and we're going to show later how that works. So basically allowing you to add any image that you want. Perfect. So we saw surface detection, we saw image recognition. Another thing that I want to show you is face recognition. So very similar process, scanning a QR code, redirects to a website. You don't have to install anything. We take care of all this kind of streaming to make sure that that works with your camera and it invokes the right platform. There you go. So now you can see me moving my head around and the Empire State Building literally jumps on my face. Instead of Empire State, you can put like a COVID mask or anything kind of that works better with masks or like, makeup, anything goes. Perfect. So we saw how you can upload a 3D model. Other stuff that I want to show you is images and videos. So let's show that too. So now instead of deciding to take a model from the collection, I'm going to upload something from my local storage. So let's upload this image, for example, just a straight up JPEG. And I can also decide that I want this JPEG to be placed in a specific location. For example, New York. Let's say I want to build an app, and if you open it in New York, you're going to see the Empire State Building, but if you open it in San Francisco, you're going to see the Golden Gate Bridge. That's totally viable to basically create these Pokemon Go style experiences that you can kind of embed content based on location. So you can already do that in Echo just by tagging data with specific locations. So we have this image right here, and what's cool about Echo is that we already kind of converted this image. If you go to this link, we already converted that to a 3D sticker. So that 2D image that you can, again, embed everywhere is basically a 3D sticker now that we can kind of place in different locations. How cool is that? So if you're working on an NFT project or some kind of art museum, you can literally upload 2D images and it'll be available to view in augmented reality. Let's see that now together. So I'm going to scan this QR code again, redirects to a website. Again, don't have to install anything. And if you're doing this right now with me, you can kind of scan this and see it with me as well. We can see on the phone how the 3D model looks. I'm going to do scan-AR, camera opens up. And now put your phone in front of a wall instead of the floor, because basically the image is going to go on the wall. So you can just move it around a little bit, pinch it to resize. You'll be able to basically place this kind of 3D sticker on the wall next to you. How cool is that? Super, super cool, isn't it? Fantastic. So we saw 3D models, we saw images. I want to show you videos as well. So let me just upload just a straight up video. There we go. And now let's also put it on an image. So we started out by putting a model anywhere, then we did an image in a specific location. Now let's put the 3D video on top of some image. So let's throw that in, uploading to our cloud. What happens right now is very similar to what we saw earlier. We're taking the content, we're converting it, we're compressing it. We make sure that it works on any device, anywhere, and basically making sure that you can kind of manage and deliver content of any type to any platform. So let's give it a sec to load. We can also, basically, as you can see, upload many models, many 3D assets into our project. It could be as many as you want. So maybe I'll just add some more. So let's add this fox, for example. Let's put it in Canada. Let's allow it to upload as well. Perfect. There we go. That was already uploaded. Let's give the video another sec, and then we can see it overlay a different image. There we go. So now we have the video right here. Super, super simple, very similar to what we saw with kind of images and 3D models. But now that you can see that this kind of video also has like an image target associated with it. So let's see how that works in practice. If I scan the QR code, and again, you can do that same thing with me if you're watching this live. I'm going to scan the QR code. It redirects to a website. And again, no installation is needed. Once the camera kind of instantiates, we will put it in front of the QR code. But now the QR code won't work anymore as the target like we had with the Empire State Building. For this thing, we have to use the image target itself. So here's the image, and here's the video on top of that. How cool is that? So we have the video playing on top of an image. And this image, again, could be anything you want. I'm moving kind of the video with my finger. But this image could be anything you want. It could be in a magazine, it could be your business card, and when someone scans it, they see a video of yourself talking about yourself. It could be an advertisement. Really, you're limited only by your imagination, and the ease of use is just to upload things to Echo, and it just works automatically. Perfect. So we saw images, we saw videos, we saw 3D models, we saw face tracking, we saw image tracking, we saw surface tracking, all on the same platform, easily accessible through web. Now let's dive into other things that we can do with the platform and different resources that you can use in order to kind of create applications really, really rapidly. Okay, so in the platform, you can obviously switch a theme, dark being the default, but let's kind of allow you to kind of customize a little bit. We have a bunch of resources here, like our documentation, GitHub, Slack channel, and so on and so forth. You can always reach out if you have any questions. But our documentation is basically a step-by-step guide of everything I just showed you right now. So literally just how to get a key, how to upload content, how to see it, how to share it. Really, really cool stuff around how to use Echo. And in our GitHub page, you can actually find an endless amount of open source examples that you can use right now. And I'm going to share just a few of them because, again, they're all open source and you can really kind of play around with them, and start the project really easily. So let's just open a few ones just to kind of show you what are the use cases of kind of augmented reality and virtual reality and so on and so forth. Let's open a few of them. Yeah, there you go. So you can upload content, basically watch Disney shows with video and 3D model automatically. How cool is that? Or you can upload content around interior design, basically upload content and basically create this kind of cool interior design demo. Or here's another example for a game that you upload some tracks, some car, and then you can kind of build in an application with gaming that later we're going to see how you do that with the Unity game engine. Or here's an example with image target that you can bring a museum to life with images and videos just by kind of overlaying images with new content in augmented reality. Or here's an example of remote work, obviously very relevant today. Literally have conversations with like a digital avatar for a person instead of having them in the room. Or here's another example that later we're going to recreate together of like this COVID tracker, and basically see how COVID spreads around different continents. Here's another example of a solar system that basically is an educational app that you can upload stuff and overlay that with information. Or here's an example of a living room, basically a living room inside a living room that you can kind of share a video inside. Very, very cool stuff. Or here's a more topical kind of election demo that you can see results in real time, kind of send data through the cloud. So you mentioned data, let's see how that works. So in Echo, you can actually manage all the data that is associated with your assets. So each content, so the skyscraper or the image has metadata associated with it that you can change and basically stream through the cloud as well. We have the subscription page, basically allows you to monitor how much bandwidth, storage, and API calls you're making, basically how much you and your users are kind of using the application. You can monitor locations, what servers are using and kind of serving your application. Remember, we added that content in Canada and New York, so we have that here. Here's the image in New York, or that Arctic Fox in kind of Canada, so we can see everything here in the distribution of users as well. We can kind of monitor the security application, add multiple users and kind of collaborators to our project. And the insights page, we can actually see how your application is performing. So what content is being streamed. So now we just stream that per building, so we see this kind of surge in usage. And basically monitor how your application is doing. If you're building something, again, going back to the example of e-commerce, if you have two couches, one is green, one is red, you can basically have a bunch of couches together and kind of see which one sells the most, the green couch or the red couch. You can monitor your users across the world, where users are coming from. You can convert and compress data. So for example, if you decide this 3D model, you want it to convert it to a 2D thumbnail, or you want to convert it to a different format, or that you want it to be decimated and compressed by 43%, you can literally do that just with a few clicks. And that model will kind of result in a smaller size model. Same with images and videos that you can kind of compress and convert to different platforms and different file formats. You can edit assets inside the console. So let's say Christmas is coming up and we want to change our assets to reflect the Christmas spirit, basically inject seasonal content and change content based on periodic updates. So we can go literally inside the Echo platform and then decide that we want this building to become, let's say, red instead of green. So let's try to do that. Hopefully it will load. See? If not, I'll come back up later. Yeah, screen isn't loading, that's okay. But you can basically in the screen kind of change textures and change the animation of the content really with just a few clicks. Let's give it a second. If it doesn't, I'll just move on. That's all right. And in the customized page, you can basically overlay the data with kind of buttons and interactions and your logo, add music, add a background, basically allowing, if you're, let's say, again, building an NFT example or an e-commerce example or a game, you can basically add buttons and information on top of the application, like your logo, something like buy now or whatever. And in the tutorial page, we have so many examples for you to choose from that are all kind of open source and things that you can build with Echo. We already discussed some of these examples. So all of them are here, things that you can build for art or Here's a cool example of a makeup tutorial that one of our engineers built. Really, really cool and engaging stuff around image tracking and model tracking, and really, really cool kind of stuff that you can build, all open source for you to use for free, so definitely check that out. Another example is our inspiration page. That is still an amazing example of what people have built with Echo, from NFTs to home design to art installations. Really, really cool and engaging stuff. It's all here. And basically things around AR and VR and COVID and all these kind of amazing things our community have built. If you build something with Echo, let us know in the Slack channel, and we'll be happy to feature you as well, to basically show the community what you've built. So definitely check out this page as well. Okay, so let's recap. What did we see so far and what we're going to see next? So we saw how you can upload content really easily. We saw you can drag and drop the content, choose content, and then see it automatically on your face, on the floor, on an image. And we saw a lot of examples of how to use augmented virtual reality in the world and how to kind of inject 3D content in different use cases. Everything we did so far was very non-technical. Drag and dropping stuff, playing around with the console. And that's, again, something that we really kind of pride ourselves in, how easy it is to build applications. On the floor, on it. And we use augmented virtual reality in the world and how to kind of inject 3D content in different use cases. Everything we did so far was very...
Why is the audio such shit? Oh, I stopped it. Nobody's watching it. Nobody's watching it. Nobody is watching it. No, the audio's completely screwed up though. Yeah, because the audio's, you can't hear it all the way to the stage where that's not. I know. Fix the echo. The audio's really shit. I don't know why. Fix the echo right now. I don't know why I have to fix the echo.
But later on, import the file they put on like
YouTube.
their Gmail, just put on our YouTube.
Okay. I mean, nobody. Okay, so I'll just play. Should I play it? Wait a minute. I'll just say we have our next live speaker at. What time? Wait, 7, right?
Yeah.
I turned off the AC, hopefully. Wait, how many submissions do we have?
Like 17, 18, what? Yeah, I'll do it. 1 second. Yeah, can you check my submissions? Damn, bro. I'm actually so mad at myself.
Why?
I was stuttering so much on the
We have 19.
Yeah, that's good. 19 is fine. Between 10 judges, 2 per judge is fine. Secondly, even 8 judges.
Yeah.
So do you want to, so the verb bar judges, how are we going to judge them?
Just Banco, bro. It's a Banco pick.
We just send them to bank.
Make sure it's muted, by the way. Is it muted? Make sure.
Hello. Can you go in the other room and see if it works?
Okay.
Like if it doesn't like lag.
Hey Dominic.
Okay.
Hi
How's it going?
Dominic.
Hey, what's up? Can you hear me?
Yeah, we can.
Yeah, we can hear you.
Oh, amazing. All right.
Yeah. So right now we're just live streaming on YouTube, like right now, currently. If you want, I can send you the link right now. Actually, can you?
Yeah. I'll
Yeah,
send you
please
the
do
link.
that.
Yeah.
Share it with some of my friends
Yeah.
Yeah.
so they can join the stream.
Yes, sir.
Mhm.
Oh, looks like I think our dev post announcement went out, so there should be people joining very soon, hopefully.
Perfect.
Yeah, we're just checking the audio, so if you can wait like 1 minute. We were having problems before, so just making sure it was working
Right.
on the stream.
Sure.
Yeah, so just like we can start in like 2.
Get a virtual background going here.
Yep. Yes, sir.
Doot.
Yeah, just checking it, and then if it works,
Okay. Cool.
yeah.
I think this is a recorded kind of guest speaking thing, so we can just start right in without any wasting time.
Yeah.
So
So hi, my name's Nurik. I don't think we talked before. I'm one of the vice presidents at Youth Code Foundation. It is a pleasure meeting with you, and I kind of look forward to hear what you're talking about.
Absolutely.
Right.
So I guess
I'll first do an introduction, and then we can move on with the content. If that's good with you. Yeah, so
All right,
for
perfect.
the people listening at home, Dominic's journey from Ghana to becoming a technological entrepreneur and pursuing a PhD in computer science at a prestigious university showcases his determination and technical prowess. As an executive and CTO at V Incorporated, Dominic's talk on problem evaluation will shed light on how to identify and tackle challenges effectively, drawing from his experiences in driving digital transformations in financial institutions.
yeah, and just as a note, by the way, Dominic, is V right, not Vi? I think we discussed this.
absolutely,
Okay,
absolutely,
okay,
yeah.
let's go.
It's
Let's go.
You got it. You got it correct.
Alright.
Okay. So thank you for that introduction. I'm just gonna get the PowerPoint up so I can start right away.
Yes, sir.
Yeah.
Yes, sir.
All right. So do I have the ability to share my screen?
Yeah, you should, right?
You gotta
Yeah.
do that for me.
Let's see if he does. Oh, sorry.
All participants.
There we go.
Yeah.
Now you should be
Wait, I
able
think
to.
there was another thing.
Oh, there.
Yeah.
I mean, same
Good.
thing.
Yeah, so I think you can share now.
All right, let me try and locate where that thing is. Can you see my screen?
Yes,
Yep.
sir. Yep.
Yep.
All right, let's go to slideshow. All right, I guess you can see problem evaluation, right?
Yes. Yes.
Yep.
All good.
All right, perfect. All right, so once again, my name is Dominic. I'm a first-year PhD here at Purdue University, and I'm also the CTO of V Incorporated, like you mentioned. And if you're wondering what V is basically a credit card company. So you can check that out after the presentation. But let's jump right into it. So I'm very, very glad and honored for the executives, giving me this opportunity to share my thoughts on problem evaluation. And essentially what we're going to talk about today is how to understand exactly what problem you're solving and understand exactly if you're solving the right problem and whether the problem you're solving is worth it. So if you look here, it says lessons for the unicorns of tomorrow. All right, so let's jump right into it. Okay, so this is a hackathon, and I'm sure all your participants are going to be building something.
Yep.
They're going to be building a product, they're going to be building a service, probably going to be building a website,
Right.
whatever it is that you're doing.
Right.
Most likely it solves a problem, right?
Yep.
So here I have here that problems are usually the basis for all kinds of innovation. Every innovation that you're seeing today is is here because somebody thought, most likely there's a problem and they have to fix it.
Right.
Sometimes people have ideas without problems, right? Sometimes, think about the pet rock example. You guys know what a pet rock is?
Of course, yes.
Okay, all right. So, try coming up with, like the problem that solves. That doesn't really solve a problem, but it was really successful.
Right.
But that doesn't mean that, you should go that route in coming up with, like ideas.
Yeah, definitely.
Nonetheless, these logos are pretty familiar. I'm sure you've seen these logos before. You've seen the Uber logo before, the Airbnb. And this one, maybe if you don't know what that is, that's Peppa Pig.
Yep.
Underneath it are the valuations of these companies.
Right.
So Uber is currently worth $102 billion. Airbnb is worth 96, and Peppa Pig is worth $4 billion. I bet you didn't know that.
Nope. I
That's
did not know that,
crazy.
man. Yeah. Okay.
And if I were to ask you the question above, right, what problems do these platforms solve? You'd probably come up with like something like this. Like with Uber, you're probably having a hard time getting to the office, so like that's a problem, right?
Yeah.
And Uber comes to the rescue, helps you fixes that.
Right.
Airbnb, you're trying to find the perfect accommodation for your upcoming trip.
Yeah. Right.
That's where Airbnb comes in and saves the day.
Right.
For Peppa Pig, apparently, I need help keeping everything during this rainy day. And that is the premises for Peppa Pig. Peppa Pig is basically entertainment for kids.
Right.
Yeah.
Can you guys hear me?
Yeah, we can.
Yeah,
we
we
can.
can
We
hear
can.
you.
Yeah.
All right, perfect. All right. So, like we're going to have to take a deeper look into, why these companies are so successful. They're so successful because they're solving a problem that was actually worth solving in the first place, right? So, typically, right? I encourage most of your participants to not just do this for, like gaining experience, with technologies. Like, for instance, maybe you want to gain experience with Python or something like that. This hackathon, you should do it so that you can actually learn entrepreneurship and how you can actually start something,
Right.
from scratch, and then eventually, come up with something like one of these really big companies. Because deep down inside, I know all of you want to become like, the Peppa Pig guys or the Elon Musk guys.
Yeah. Yeah.
Nonetheless, this is the process typically that you're going to go through. The first thing is you're usually going to come up with an idea. You're going to plan it. You're going to execute. And the scaling and hypergrowth part, not so much here on the hackathon, but in the real world, usually these are the two longest steps, right? After you've actually built the product, you're going to scale the product, and then you're going to enter what is called hypergrowth. At this point, you've probably made enough of a dent in the world that, people actually care about you. You probably have investors at this point. People are actually, excited about your future success, so on and so forth.
Yeah.
But something happens before that, and that's, this section here, right? So you first need to figure out exactly, what problem that you're solving. And most importantly, you're going to have to evaluate the problem that you're solving. We're going to look at some examples in a bit. So, this is kind of like what we all want, right? Want to be this guy here, want to be Jeff Bezos,
For sure.
right? It would be nice to own some, Amazon stock right around this time.
Yeah, definitely.
But nonetheless, essentially, come up with the idea, go through this process, and, usually within 6 years, right? And that's the statistic. Usually within 6 years, you should be able to reach unicorn status. Unicorn status basically meaning that your startup is actually worth like $1 billion. And, well, if you're able to do this, you've clearly done something right. So we're going to actually talk about, what exactly did you do right, especially with respect to a problem evaluation.
Right.
Well, if you don't do your problem evaluation correctly, this can happen to you. you can actually spend 6 months, going through the ideation process, the planning process, the execution process, God forbid, the scaling process and the hypergrowth process, only to end up with a company that's worth less than $1 million. And just for your information, any startup that you start, like for instance, all of the hackathon ideas that you come up with, in the eyes of like investors, angels, and VCs, is automatically worth $1 million, right?
Yeah.
You like if you were able to get a VC or an angel to actually sit down with you, look at your idea, you could potentially sell it to them at this stage, even though you have no customers, for $1 million. And that's pretty standard. And you basically spend 6 years of your life, doing nothing. And like, I don't want you to do this, right? So we want to be this guy, right? We want to be Jeff. How do we do that? Before we look at that, I just want to make sure you understand that, it's not just financial. There are really, really good reasons to evaluate the problem that you're solving. Essentially, it's going to save you some time. It's going to help you prioritize, and is going to give you the opportunity to come up with innovative solutions for the problem that you're solving.
Right. Yeah.
So, drum roll. How do you actually do this?
Yeah.
Okay. All right. So let's say you have a problem, right? I'm going to give you a very, very simple example. Let's say the problem that we're trying to solve is the battery low problem. If you've ever had that problem, put a 1 in the chat. I've had that problem. When your battery goes low, bad things start to happen. Your apps start to run slow. You that's the time you're hoping you don't have to order an Uber, because Uber is going to kill your battery. And it sucks to have a low battery. That's the problem. Usually problems, and for those of you that probably don't understand like how to formulate a problem, just think about pain. Anything that causes pain is a problem, right? Like our battery being low is a problem, right? The same way if you don't have Wi-Fi, it's a problem. So ask yourself 3 questions, right? The first question you have to ask yourself is, how many people are affected by this problem, right? And, your answer could be something like, just one person, me, or, maybe my entire class is affected by this problem, or, the entire state, I think, is affected by this problem. So this is all up to you here. You basically, talk about that, in the red bubble. And then you move on. After you've answered the red bubble, you move on to the yellow bubble. You talk about how intense is the problem. When I mean intensity, we're basically referring to how willing is the person who is suffering from this problem, like what's the degree to which they're willing to solve the problem, right? Or, what is the intensity in terms of, let's imagine, the problem was, let's say, an oven, right? How hot is it in there, right? Is it a problem that they can just, ignore, right? It's not really that hot, or it's a really pressing problem, right? So if you think of a problem like, you got to go to the bathroom, you can't really put that off, right? Going to the bathroom is a problem that you have to deal with now. If you don't deal with that problem, well, the problem is going to deal with you. So, that's an example of a high intensity problem. So that's a second evaluation step. The third evaluation step is how frequently does the problem occur? You have to think about that. Is it something that occurs, once every year, right? Or once every 4 years?
Right.
Or is it like, the solar eclipse? Is it like, you're building a startup that takes really cool images of the solar eclipse, but this thing doesn't even happen that often, right? It happens every once in a while, or every once in a blue moon, like people like to say it. Or you might be solving a problem that people have like every day. So ask yourself, how many times a day do you charge your phone? I charge my phone at least 2 times a day.
Yep.
Right?
Same.
So I'm having that problem every day. If you think about the people that own Teslas, right? How often do they have to charge their Teslas or their like electric cars? You know, that might be a problem that they're facing.
Right.
So once you have these three things in place, you're going to start to get a sense of whether or not this is a problem that is worth solving. This problem is actually worth giving your time, right? All right. So let's look at some examples. We already started talking about one of the examples. So the first example here, a low battery, everybody has that. It's obviously a high intensity problem and twice a day. All right, when you got to take out the trash because it's stinky, right? Who has that problem? Everybody has that problem. Everybody has trash.
Of course.
Can you think of anybody that doesn't have trash? Everybody has trash. And it's a high intensity problem because of this word here, stinky. Right?
Right.
If you take out stinky, you can actually deal with it because it doesn't stink.
Right.
As soon as it starts to stink, then it becomes a problem.
Yeah.
Right?
Yeah, right.
Yeah. And the frequency of the problem is basically every day. Okay, so here it says when you can only get a clear image by recording in 8K, right? Let's say, like, let's go back to that example of the, taking an 8K footage of the solar eclipse. This doesn't really happen that often, right? Maybe once every experiment, like the diagram shows here. And, the intensity is pretty high. Like, you have to take it. If you don't take it and you miss it, I mean, well, you've missed it. Unfortunately, you're going to have to wait another, blue moon to get a chance to do that. And just a few people are affected by it. So as a rule of thumb, for hyper success, if you want to be like Tesla, you want to be like Facebook, you want to be like these companies, if you want to have massive impact, not that every company is going to be like this. This is typically the configuration that you find them in, right? The configuration that you're going to find them in is you're going to find them in, like having like a high number for multiplicity, having a high intensity, and having a high frequency, right?
Right.
So if and I want you to actually, look at the problems that you identify with, the solutions that you come up with and actually evaluate them this way. Actually think about, who is affected by this. If it's a lot of people, wow, you check one of the boxes, right? If the intensity is really high, you've just checked another box. You're just like one box away from Elon Musk status, right? And frequency, you look at that and it's pretty high. Warning though, not every problem is going to be like this, right? Unfortunately, there are some problems that are probably going to be missing the frequency, but it doesn't mean that it's not going to be a useful solution or it's not going to have global impact.
Right.
And there's some problems that are not going to have a lot of multiplicity, right? Because think about it, imagine if, you were the owner of a private jet rental company, you rented out private jets.
Right.
How many people can actually afford a private jet? Very few,
Yeah.
right? However, they pay top dollar for it.
Right.
So whatever you'd lose out on, the middle class not joining in, the high class basically cover for it, right?
Right.
Exactly. But typically, this is the formula for success. And there's one bonus question, right? And that's how I'm going to end the talk. It's a pretty short talk, and there's one bonus question that you always have to ask yourself, right?
Right.
You take a step back. After you've done this, you take a step back, and then you ask yourself, if you do not solve this problem, who is going to suffer the most? So you take a step back, right? So let's say, we're trying to solve the low battery issue, right? We take a step back. Let's say we want to do a solar powered, power bank.
Right.
And so, if we decide not to do this solar powered power bank, who is going to suffer the most? Write down a list, the top 5 people that you think are going to suffer the most. And that's going to give you insight, right? It's going to give you clarity to understand exactly who it is that you're going to target after you have your solution ready, right? And how you're going to move ahead throughout that entire, process that I showed you earlier, so that you can achieve the kinds of success that some of the greats have achieved. And I want the participants to have fun. Just it's a fun process, right? Basically come up with like these really, really cool ideas. They should solve problems. They should somehow, conform to this. Almost every problem, you can fit it with this framework here. And I think with that, I am essentially going to end the talk.
Yeah, thank you so much. It was a great talk. I do have a couple questions for you though.
Go right ahead.
So, how do you kind of approach problems that might seem kind of interconnected? Like, say you solve one, but it affects negatively the other, and you can't seem to.
Could you give me an example of that?
So, like, say you're building an app, okay? I know it's not really in terms of problem evaluation, but anything classified as a problem. Say you're building an app.
Absolutely.
Say you're building an app. You have 5 errors. Okay. One of these errors, you tried to fix them, but now another error shows up because you fixed that first error, and it keeps on happening until you don't know what you're doing anymore. You're just stuck in this loop, right? I know that's not really like the best example, but like it's kind of that type of logic, right?
But I think you've illustrated it as clearly as you can, and like thank you for doing that because you've clarified your question. I would say sometimes it is true. Problems are interconnected.
Right.
So there's some kind of dependency, right? Sometimes.
Right.
Right. If you solve one problem, it actually sort of leads to another problem.
Yeah.
Just think about it. Has Uber created a problem? The solution to the problem that we had earlier, has Uber itself created a problem? Can you think of a problem that Uber has created?
Right.
We can take a step back, right? And think before cars, we had horses.
Right.
Right? Yeah. And a smart genius, woke up one day and said, you know what? I'm sick of these horses.
Right.
We're going to make a car. They made cars. They made gasoline-powered cars, right?
Yeah.
Cars that are powered by fossil fuel. Now, that in itself was a solution, right? Did that create a problem? Yes, it did. Right? Greenhouse emissions. And electric cars, even though they've solved one problem, they're probably going to introduce more problems down the line.
Right.
So problems are definitely interconnected. However, like you clearly mentioned, just take your wins as you solve them one after the other. If you solve a problem and another problem shows up, at least you've solved the first problem. You have a new problem to deal with. That's a new opportunity.
Yeah.
It's a new opportunity for you to, in my language, make some more money, make some more revenue, right? Because you can introduce new products into the market, right? Or you can just, understand that in the case of your debugging example, you squash the bug. A new bug is here. You're going to squash that and keep squashing, right? You're probably going to get to a point where you're going to have a stable platform and you should be able to release that platform.
Yeah.
So that's the answer that I have to that. You have any more questions?
Yeah. We actually have a question from Arf. So he said,
Perfect.
Do you ever have a artist block when it comes to solving a problem, and how do you work around it?
Do you ever have what?
Do you ever have a artist block when it comes to solving a problem, and how do you work around it? Like an artist block meaning like, you're doing something and you just don't know what to do.
So that's an artist block?
Well, yeah. I mean, that's what I'm assuming.
Okay. All right. So you're solving a problem and you're stuck.
Yeah.
Solving that problem.
Yeah. Basically. Yeah. That's
okay.
Yeah.
Well. I would like to say that all problems, if defined clearly enough, have obvious solutions. And it's pretty true, right? If you can identify that, hey, the reason why I'm shivering is because the temperature is too cold. Well, the obvious solution is to raise the temperature,
Right.
isn't it?
Yeah. Right. Right.
Exactly. So I would say, if you're trying to solve a problem and you're stuck, right, take a step back, try and redefine the problem again,
Right.
maybe in different terms,
Right.
right?
Right.
And that could be in the form of talking to a friend, sharing the problem, probably evaluating it through the method that I just showed you,
Right.
right? And that's going to clarify it. And once it's clarified, you might actually come to a point where you realize I was probably solving it the wrong way. I should go this way instead.
Yeah. Right.
Yeah.
Yeah. That sounds.
Powers messing.
Yeah. No, I think it's fine. But yeah, that sounds amazing. It was great talking to you. It's great having this talk. We'll
Absolutely.
have this on our YouTube website. Hopefully, people come to view it over time. It was an amazing talk again. And yeah, thank you so much. It was great.
Thank you for having me, man.
Yeah. No
All
problem.
right.
Man. Okay. Yeah. See you, man.
So if any one of them want to reach me, I'm on LinkedIn.
Yeah.
They can just go on LinkedIn, just send a message.
Yeah, actually, I forgot to ask you this, but is it all right if we have your contact info on like the dev posts, so like they can contact you and things like that? They can.
Absolutely.
Okay,
Absolutely.
cool.
Absolutely.
Okay.
Go right ahead.
Yeah, that great, amazing, sounds good. Okay, man.
All right. See ya.
See you, man. Bye bye.
I think something got completely
makes again, a huge difference, or creates a differentiation between boys and men. And the reason why this is important is that you have to be able to put yourself in the feet of users and try to figure out what are you going to do, right?
Right.
Now, disaster recovery, right? You're building a bridge. You have to understand that what if that bridge doesn't work? How are people going to be able to go from point A to point B when the bridge is not there?
Right.
Again, if you are building cloud-based system, your life is much simpler these days. This problem used to be a lot more complex and a lot more difficult and a lot more expensive. Not as much anymore, right? You do have better tools available, but again, it's a complex problem to solve.
Right.
Very complex problem, from database to routing of the messages, accessing website from wherever. Important, right?
Right. Yeah.
I don't have to delve too much into it, but when you are building the software, you have to understand how do you build a secure infrastructure. These days, the difference between hardware and software is gone, right? Everything is software. So you have to understand what is secure, how do you implement security, and how do you monitor what's going on, right? It's very, very important.
Yeah.
Now, I think the last point in this series is that, project management. When you are building software, it's very important to understand what is your deployment strategy, right? CI/CD. How do you do agile development? How do you track issues? How do you keep cost under control, and so on and so forth?
Right.
This is, again, not something that a lot of people may think about, but it's critical.
Yeah.
It's critical. This is what makes a software that is workable, a business that's workable, versus a cool project, right? So, in summary, right, all these things that we talked about in the first slide, it's not boring. Trust me, I come from experience. It's fun.
Right.
It's challenging. Solving these problems are as much fun and as challenging as coming up with an idea and implementing it in hackathon. The other thing that a lot of people don't understand is these need to be thought through upfront.
Right.
This cannot be an afterthought. It's very, very important that you put a design and all this concept at work right from the beginning. What is the advice? Think software as any physical product.
Right.
Think about it. It makes a big, big difference if you start thinking like a physical product. You have seen, whether it's hardware, when you use internet doesn't go down. It's a complex stuff, right?
Right.
When you use an electronic device or a car or whatever else, they all think about all the things that we talked about, right? How do you make sure that your product is useful? How do you make it beautiful? How do you make it reliable? Right? It's extremely important and critical that you do this. And it's funny, but like what they say is, when did you say they would have our resumes printed on the bridge, right?
Yeah.
Build it like you own it.
Right.
Build it like you own it. And your name and reputation. You're a professional, and your name and reputation is your currency.
Right.
And it's very, very important that you build it like you own it.
Exactly.
And I hope through this, in half an hour, you have been able to understand that how the software development should not be just about cool idea and cool implementation.
Right.
And I hope nobody has to pay you to do all these things, or hopefully you will think about it when you're doing the product and design and implement it.
Right.
It was a pleasure talking to you, Palash.
Thank you.
Let me know if you have any questions.
Yeah, I do actually have a couple of questions. So I know you were talking about like manageability, complexity, UI, user experience, usability, right? How do you kind of strike a balance between a clean and simple design versus like incorporating all the necessary features to have that unique user experience in your platform?
So, you know, the best example I can give you is what Apple did to Microsoft in a way, right? A simple, good design doesn't mean it's less functional.
Right, right.
You have to think about how do you make the life of people easier? How do you make them use your product better?
Right.
That doesn't mean it has less features,
Right.
right? So it's not one or the other. At the core of it should be a product that's clean and easy to use.
Right.
And of course, the features, have to be there as well. But if I have to start with anything, I would start with plain, simple, useful design, and then constantly think about how do you implement features without compromising on the first principle.
Right. Okay. That makes sense. Okay. I mean, that's really all I have for you today. I mean, it was great talking to you. If anyone at home has any questions, can I like give them your email on like dev post? Is that okay?
Sure, absolutely.
Okay, then yeah. Then maybe expect some questions, hopefully, over the next couple of days. And yeah, it was great meeting you. It was a great talk. I learned a lot. And it definitely impacted me on how I view like software development as like a whole. Like in terms of usability, manageability, and all of that. And so thank you so much. Thank you so much for that.
No, thank you for the opportunity. And, I would tell you that, I've been fortunate to work in the financial industry, which is one of the toughest domains, and I'm sure there are a lot of other domains that are tough as well.
Right.
But reliability, scalability, resilience, and everything else that we talked about are critical.
Of course.
Extremely critical.
Of course.
These are important concepts, and I hope as your team and people who have gotten into Hackathon are able to take their ideas and bring successful products out to the market, and look forward to it.
Right.
Best wishes.
Yep. Thank you so much. It was great meeting you. Bye-bye.
Take care.
Take care. Yep. Bye-bye.